Hello and welcome to another AP3 video. And in today's video we're going to go over SAT math problems, more specifically advanced math problems in the SAT. So we're going to go over factoring, discriminant rule, and many other things that are really important in the SAT. The first question shows the following. Which of the following is the solution to the given equation? So we're given the following. X plus 2 multiplying by x plus 3 equals x minus 2 multiplying by x minus 3 plus 10. Now we can do one of two things. We can either plug in every single value that's given in the A, B, C, or D, or we can expand it and then plug in the value. Both ways works, but in this example, I'm going to show you how to do it when you expand both sides of the equation. If we expand the left side, I'm going to do it in red. So x multiplied by x equals x squared, and then 2 multiplied by 3 equals 6. And then x multiplied by 3 equals 3x. And then 2 multiplied by x equals 2x. And if you combine like terms, we would get x squared plus 5x plus 6 equals the right side. And if we do the right side, which I'll do in green, we would get the following. X plus x times x equals x squared. And then x multiplied by negative 3, we would get negative 3x. And then negative 2 multiplied by negative x, we get minus 2x. And then negative 2 multiplied by negative 3 actually equals positive 6, because two negatives equal a positive. And then we would get plus 10. Again, if you combine like terms, you would get x squared minus 5x plus 16. So now all we have to do in this example is just now plug in either A, B, C, or D, and see that if we plug in either value, either A, B, C, or D, both sides should equal to each other. So let's start off with B, for example. So in order to do this, you either guess and make sure that it actually works in the equation. I'll do it in yellow. Actually, I'll keep it in red. Actually, if we make x equal 0 to square to the 0 doubled, or sorry, it's late. 0 to the power 2 is 0 plus 5 multiplied by 0, that just equals 0 again, and we have plus 6 on the left side. If we do it on the right side, we will get the following. 0 to the power 2 equals 0, and then negative 5 multiplied by 0 again equals 0, and then we get 16 by itself. So we get 16 and then 6 on both sides, which they don't equal each other, obviously. So B is definitely not an answer. But let's plug in A. Let's plug in 1 in this problem. If x equals 1, we get the following. 1 to the square root of 2 equals 1, and then 1 multiplied by 5 equals 5, and then plus 6, we get 12 on the left side. On the right side, if I were to do 1 to the power 2, we get 1. And then 5 multiplied by 1, we get 5. So 1 minus 5. And then we get 16 by itself. So we would have 17, if we combine like terms, 17 minus 5, which equals 12. And as we can see in this problem, both sides equal each other, meaning that the answer to this question is A. Now, it is important to note that in these types of questions, you can either plug it in Desmos, or you can even skip the whole factoring part and just plug in A. But I just wanted to show you what to do if you wanted to expand it. But to make this question as easy and to solve the question like really quickly, just plug it in Desmos so you're not wasting time on easy questions, and you're consuming or saving your time for the harder questions that you're having trouble in the SAT. Okay, let's do another factoring problem, but it's going to be relating to the vertex, or using concepts from the vertex rules. The question asks the following. What is the minimum value of the function f defined by f of x equals x minus 2 squared minus 4? So we can rewrite that as f of x equals x minus 2 multiplied by x minus 2. And if we expand that, that just equals x squared minus 4x plus 4, and we just get the minus 4 from the equation. which then the 4's just cancel out because the positive and the negative of the same number just equals 0, or a coefficient. So then we're left with x squared minus 4x. So in order to find the minimum value, we need to understand how to find the x value in the vertex. And that formula is x equals negative b over 2a. Now, in a regular quadratic equation, we get 0 equals x squared plus bx plus c, or ax squared. So the a and the b value will be used in order to find the vertex value. And in this problem, we can see that the a value equals 1 and the b value equals negative 4. And if we plug that to the x, we get negative multiplied by negative 4 over 2 multiplied by 1, which just equals positive 4 over 2, which equals 2. But that's not the answer. They're asking for what? The minimum value, or the y value of the vertex. And in order to find the y value of the vertex, we need to find the x value of the vertex. We already given, it's 2, because of the vertex formula rule to find the x value. So now all we have to do is plug in x, or 2, into the equation right here to get the answer, or the minimum value. So when f of x equals 2, it equals 2 squared minus 4 multiplied by 2, which just equals 4 minus 8, and it's negative 4, and that is our answer. Now, in the way that it's like graphed, the minimum value is basically where a parabola looks like this. And in this point right here, that's the minimum. However, I'll draw on the left side. If they're asking for the maximum value, it looks like a graph like this. The point over here on the top part, that would be the max value. But in this equation, they're asking for the min, and the answer is negative 4, and that is A. It is important to know that in these types of problems, again, you can plug it in decimals. I'm here to show you little shortcuts to solve questions as easy as you possibly can. I'm not sure I'm saying this correctly, but we're gonna go with it. And the discriminant rule basically is b squared minus 4ac. Now you might be asking, what does that mean? Where do we get the bac from? Like always, we use it from what? The quadratic equation. So 0 equals ax squared plus bx plus c. And what does this give us? What does this show us? Well, if b squared minus 4ac equals 0, that basically means that there's one solution, or there's one x value that solves the equation. When b squared minus 4ac is greater than 0, and there's two solutions. And when it's less than 0, there are what? No solutions. And it's important to know because this is not in the reference sheet in SAT. So this is very important to understand and know. Very easy to memorize. Just know when it equals 0, it's one solution. When it's greater than 0, 2. And when it's less than 0, no solution. And now because we know that rule, we can solve the problem now. And the problem asks the following. And the given equation, C, is a constant. The possible equation has no real solution. So that is important. No real solutions if C is greater than N. And they're asking us the least possible value of N. And this is a lot of information to take in. So let's go step by step. They're telling us that the equation has no real solution. So out of the 3 discriminant rules that I show, which one are we going to use? The one where b squared minus 4ac is less than 0, basically meaning no solution. So now we plug in the a, b, and c value to get the answer. So we can see that if we rewrite x squared minus 34x plus c equals 0, we can receive that a equals 1, b equals negative 34, and c equals C, because C just equals it itself. Now pay attention, because it's going to get a little bit tricky now. Okay, so now we know our A, B, and C, and then we just plug into the discriminant rule. So B squared, or 34 squared, gives you 1,156. And then minus 4AC, or minus 4, multiplied by 1, and multiplied by C, less than 0, because it's no solution. We get 1,156 minus 4C is less than 0. And now we're looking for where C is greater than N. So it's kind of like a regular inequality or regular equation where we're solving for C. So now all we have to do is isolate C. So we do minus 1,156 on both sides. Minus 1,156. And then we're left with negative 4C is less than negative 1,156. And because we want to isolate C, we divide everything by negative 4. Oh, I don't know why it's doing that. I'll just do it on the right side. And it's important to know that whenever a coefficient is negative and you reverse it to a positive, the sign changes as well. So we would get C is greater than negative 1,156 over negative 4.